Your screen flickers, the taskbar vanishes, returns for a fraction of a second, then disappears again. Your desktop is collapsing in on itself. You are stuck in what is known as the Windows Explorer crash loop. The core process responsible for your desktop environment is failing, automatically restarting, and instantly failing again. Breaking this cycle requires two specific tools: an administrator account and a working keyboard. No operating system reinstallation is necessary. This is a software conflict, usually a background process clashing with the operating system. We can isolate the specific file responsible and neutralize it while keeping your personal data intact. The first step in troubleshooting a volatile system is building a fallback point. Press the Windows key and R to open the Run dialog. Then type sysdm.cpl to launch System Properties. Navigate to the System Protection tab. Check your primary hard drive, usually the C drive. If protection is marked off, click Configure and enable Automated System Protection. With protection active, click Create to manually generate a restore point. Name it Before Fix and confirm. This allows you to revert to this exact state if a command causes further instability. Now we must stop the crashing. Because the taskbar is unresponsive, press Ctrl, Shift, and Escape simultaneously to deploy the Task Manager directly. Scroll through the background processes until you find Windows Explorer. Right-click it and select Restart. This forces the shell to reload. While it does not fix the underlying bug, it provides a temporary window of stability, giving you the time needed to execute deeper repairs. We will start by clearing corrupted temporary files. In Task Manager, click File, then Run New Task. Type CMD, check the box for administrative privileges, and click OK. The next command will intentionally turn your screen black. Your desktop interface will disappear until we manually restart it. In the command prompt, type taskkill/f/im explorer.exe and press Enter. The visual interface is now shut down. Next, type del/f/q %local app data \Microsoft \Windows \Explorer icon cache asterisk and press Enter. This destroys the current icon cache. Follow that with del/f/s/q %local app data \Microsoft \Windows \Explorer thumb cache asterisk and hit Enter to wipe the thumbnail cache. Finally, type startexplorer.exe and press Enter to bring your desktop back online. If corrupted visual caches were causing the loop, this purge forces the operating system to build a fresh foundation. If the crash persists, we must analyze the system logs. To find the source of the failure, open the Run dialog, type eventvwr.msc, and press Enter to launch the event viewer. Windows uses shell extensions, third-party mini programs that attach to the Explorer process to add menus or features. A bug in just one of these files can crash the entire shell. Filter these logs to isolate the moment of failure. Under Windows Logs, filter for Event ID 1000 to see critical errors. In the Details pane, locate the faulting module name to identify the specific file that triggered the crash. You now have the exact name of the file responsible for the failure. Instead of trying random fixes, you have identified the specific point of collapse. To test this finding, we use the System Configuration utility to strip the operating system down to its bare essentials. Open the Run dialog, type msconfig, and press Enter. Navigate to the Services tab. This is where we begin the isolation process. There is a critical requirement. You must check the box to hide all Microsoft services. Disabling core Windows services can make the computer unusable. Once the core services are hidden, click Disable All. Then, in the Startup tab, open Task Manager and disable all background startup applications. Close Task Manager. Click OK in the Configuration window and restart your computer to apply this sterile environment. If the system boots and remains stable, you have confirmed that one of the disabled third-party services was causing the crash loop. A successful repair ultimately results in a stable desktop. The flickering stops and the interface responds normally again. By identifying the conflict and isolating the service, you have regained control of the machine. Your final task is to uninstall or update the specific application tied to the faulting module you identified in the logs. Tracing an error log to its source and isolating a conflicting service provides a repeatable method for troubleshooting Windows. These tools resolve the current failure and provide a framework for handling future software errors.